Hello and welcome to this bonus edition of Developers Play Monster Proof. This is a special edition. We're going to play a level today that was reported by one of our players as pretty difficult and hard to understand. And so I'm going to record a video of how to solve it so that we can get that info out to the community as quickly as we can. So special thanks to our community members who are sending us emails. If you want, as a refresher, you can go from your Palace. There's a send feedback button over here. So if you click on your Palace and then send feedback, it will bring up your mail client and send us an email, and we respond to and read every single one of them. So feel free to drop us a line, and hopefully we won't be flooded by thousands of emails, but actually I take that back. Hopefully we will. So let's go back to the level in question. So we take a look here, and it's fairly simple at first, but if we scroll down in the freebies, we see there is a crossroads. So we want to first take care of that. I think I've demoed in other videos that we should take care of these first. So I'm going to take that, copy it up, and that will split the level, update it a little bit. Now we have two puzzles. One is fairly simple. That's just a simple copy it up. And I'll throw an extra Easter egg in here. Whenever you do a copy up and you have the same thing on top and bottom, you can hold down the Shift key when you click on Open Sesame. So again, hold down Shift and click Open Sesame, and it will actually use a much simpler, much quicker test on the back end, and so you'll get your answer like much quicker. So if you're feeling like pro mode and you know what you're doing, you can use Shift to get that done more quickly. So then we come over here to the second part of the problem, and this is where it gets a little bit sticky. Unfortunately, to solve this part of the puzzle, we're going to need to look at one of the statements that we were hoping you wouldn't have to worry about, basically. So we're gonna close this guy up and make a little bit of room. And what happens is when we copy this up, this statement, we lose the vampire, and we get a question mark. So on the bottom here, we have a similar looking thing where the Viking elf is less than or equal to something on the right, but the vampire disappears. And so we need to understand a few things that we were hoping you wouldn't have to deal with. So first, a little bit of a refresher. Anytime you have these boxes that have a color other than light gray, we were hoping that you as players would not have to think about those. But it turns out in this case, this level does require it. And so there's actually two concepts we need to talk about. First is what these brackets mean. So for example, if we have, let's see if I can find an example. We'll use this one. So we have here a statement, -2 to the 31st is less than or equal to bool with the brackets of something on the inside. And we're going to kind of ignore the details of this something on the inside. But I did do a video, but I think it may not be out yet on YouTube, where we explained kind of what brackets are. But the way to think of this is that anything with these blades on the back, those are a dictionary. And so it's basically you look things up in the dictionary by using a key. So in a regular dictionary, the key is the word, like umbrella or whatever. And this bracket tells you which entry you're looking up. So here we're saying look in the Bull Viking dictionary, because the blades tell us it's a dictionary, and get the entry for, that's what the brackets mean, and then something about these two characters. So what this returns is a number. We look in the dictionary for this entry, and whatever number that is, that's going to be bigger than -2 to the 31st. And that's all this really says. And folks with some engineering background or programming background are probably following this no problem. So that's what the brackets mean. So if we kind of go from the right here, we know we're looking up something in a dictionary, and we're using the same index. We're looking up entry Viking Cyclops. That's the one that we care about. So what's all this stuff to the left then? Well, this brackets less than dash, that's our update symbol. And basically what it says is, and we'll look down at the bottom because that's where all the characters are. And so what update does is it says start with the dictionary with the Viking fairy. Start with this dictionary, go to this entry, which is identified by the Viking vampire, and replace that entry with this. So it's kind of like saying go into the dictionary and redefine umbrella to mean Sasquatch. It's basically saying take this and put it into the dictionary in that spot. Okay, so that's what this does. So if we apply these sort of one at a time, we're starting with the fairy dictionary, going to the Viking vampire entry and overwriting it with the Sasquatch. Then what we have left is an updated dictionary that is basically the same as the fairy, except that one of the entries was overwritten. Then we take that dictionary and look up the Viking Cyclops. So now let's go up to the top and think about what sort of the problem that we have. We're starting with the fairy dictionary, and we're trying to overwrite some piece that we can't, but we don't have access to the vampire Viking. So we kind of have a problem. Then we're going to take the dictionary that comes out of that operation and look up the Cyclops Viking. So does it really matter that we've updated the entry for Viking vampire, since all we're going to look up is the entry for the Cyclops? No, it doesn't. So one thing we can do, and this is the first step of the solution, is we're going to say, well, it doesn't matter that you're updating the fairy dictionary. Sorry, let me talk it through it. It doesn't matter that you're updating the fairy dictionary because the piece that we care about for this equation is not updated. We're going to look up the Cyclops, and since that wasn't updated, who cares that you're updating the definition for umbrella? We care about the definition for race car or something like that. I don't know where these words are coming from, but there you go. So we're going to get rid of this question mark by saying, hey, we don't care that it's an update. We're just going to use the fairy dictionary not updated. But in order for this to work, we need to prove for sure that the part that we're going to look up does not overlap at all with the part that was changed. So we need to prove that there's no overlap between the Cyclops Viking and the vampire Viking. And then it will be true that this statement implies that statement because the update is irrelevant to the bottom part. So how do we do that? So let's close this. So we care about this Viking Cyclops. So again, I'm going to come over to the freebies and I'm going to shift click on the Viking Cyclops. And you notice that turns everything else off. And we also care about the part of the dictionary that, or we care about the vampire, right? What we're trying to prove is that these two don't overlap. And so let's take a look here. So we know that, and this is what's a little bit disappointing, is here's the second bit that we were hoping you wouldn't have to think about, this region. And actually my explanation works. Let's ignore it for a moment. I'm going to close that. And now let's take a look at what we know about the Viking vampire. So I'm going to turn that on and add those freebies. And we're going to open this. Let's see. We know that he's not equal to 0. We know that the Viking vampire is less than or equal to 0. We know that he's non-positive. We don't know if he's positive or negative, but we know he's non-zero. Let's see what this one says. In fact, we know that this guy is strictly positive. So, we know that the vampire is somewhere above 0, and we know that the guy that we're going to look up here is somewhere below 0 or is 0. So these two facts together prove that there's no overlap between the area being updated and the area being looked up. And so these two facts taken together are what allow us to use this to prove this. So I have to activate those freebies. And I have actually not done this before, so I hope this works. Just kind of looking at, I might need this as well, I'm not sure, but I'm hopeful that this works. Nope. Okay, so unfortunately, we're going to have to get a little bit more into region. Region says the bit of the dictionary that's defined by this integer. So think of it as something that turns a number into a range, and that's probably a good enough definition for now. But what we need to do is say that, hey, the part of the fairy, oh, that's the wrong one. That's the fairy integer. Let's see, we know that he is not equal to 0, but we already know that he's equal to 1. Let me see. Okay, I think I know what is going on. Let's see. So, what we care about is the region that is pointed to by this vampire. Again, when you look things up in dictionaries, it's possible the analogy breaks down a little bit. Basically, it's kind of like saying, you're allowed to do things like look up the entry for umbrella, but then keep going on to read the definitions of the words after it. Read umbrella, and then I don't even know what comes after umbrella in the dictionary. So we have to be careful with regions, and it's a little bit out of scope. So as I said, I'm a little bit surprised that the region has become as important as it needs to be. But that's because I'm a game guy and that this is a science project. So we've kind of had a bit of a discovery along the way here, and that's really good. So what we care about is, let me back up. We're going to see what we know about this vampire and its region. So here we know that the region of that is pointed to by the vampire Viking is 3 plus, and now be careful, this is the fairy without the Viking hat. You notice that it has a different background, and it's sort of an unfortunate coincidence of this particular level that is a different monster than the Viking fairy. I hope we made that clear in the tutorials, that the hat differentiates between different versions of the fairy. So now we know that the region pointed to by the Viking Cyclops is 0 or less. And we know that the region pointed to by the vampire is the fairy plus 3. And so now we're getting closer, but we need a relationship between the fairy and the vampire, whether implicit or explicit. Hope this is making some sense, but let's see what we know about the fairy. So I shift click on the fairy, and this is good. We know that it's definitely smaller than 2 to the 64, a very big number, but we also know that it's larger than 0. Now remember, this guy is 0 or less. This guy is 0 or more. So the fairy is 0 or larger. The region of the vampire Cyclops is 0 or less. So there is still a possibility that they overlap at 0. But this third fact over here says that actually the region of the vampire Viking, which is this guy who we care about, is actually 3 more than this fairy. So it's really the region the region of the vampire is 3 or greater. So now we've proven that this guy's 3 or more, and this guy's region is 0 or less. So now we have proven by way of an intermediate variable that these two don't overlap. And it's become really clear to me that we need some kind of a tutorial on region. So for now, this is the best I can do. It's a great example. Boy, if you can understand this one, you are in great shape. And so I'm going to try Open Sesame, and I sure hope that works. Yay! Okay. The reason that it broke is because I broke the equation, so I need to reprove this one. And there we go. So that is the answer to the super hard problem pointed out by one of our community members. So if you have other ones that you found that you would like help with, send them along, and we'll try to do a video of how to solve them, because they generally are solvable. They just may require some really deep thinking. So thanks a lot. Enjoy the rest of the videos, and have a great day.